In the last lecture, we had seen different applications of the diode. The first application that we talked about was rectifiers. In rectifier, we had seen that we are having three types of rectifier, that is half-wave rectifier, full-wave bridge rectifier, and center-tip full-wave rectifier. In today's lecture, we are going to study about half-wave rectifier. Before understanding what is half-wave rectifier, we must know the definition of rectifier. Rectifiers are the circuit which converts your AC signal into your DC signal. Now, starting with our half-wave rectifier, here this is the circuit diagram of your half-wave rectifier. The half-wave rectifier can be built by using a single diode. Here, this diode is connected in series with your load resistance. The AC supply which you want to rectify is generally given to the rectifier circuit through the transformer. On the right hand side, you can see that we are having two waveforms. The first waveform, that is your input AC signal, that is V in. The second waveform, that is your output signal, that is V out. Here in half-wave rectifier, we are getting the output from 0 to pi, that is during this particular cycle, we are getting the output, that is in positive half cycle, we are getting the output. During negative half cycle, that is the duration from pi to 2 pi, we are not getting any output. Similarly, again from 2 pi to 3 pi, that is the positive half of the cycle, we are getting the output, and again from 3 pi to 4 pi, that is negative half of your cycle, we are not getting the output. So we can say that half-wave rectifiers are the circuit in which we are getting the output only during your positive half cycle, and during your negative half cycle, the output is equal to 0. Now, let us understand how we are getting this type of output. So, starting with our positive half cycle, that is the input cycle, here we are considering we are just giving positive half, right? That means because of this positive half cycle, at this particular secondary of your transformer, we are having positive term or positive value, and at bottom we are having negative value. Again, here you can see that if we are having positive at this terminal and the diode positive at this terminal and the negative at point B, and diode negative is also connected to point B. This makes your diode to be connected in forward bias. And as we all know that whenever the diode is in forward bias, it will act as a closed switch. So here we had replaced the diode with a short circuit or a closed switch. And because of this, your circuit gets completed. And whatever input we are giving, we are getting the same output across your load resistance. So here you can see that in the output, during positive half cycle, we are getting the same value as what we are giving in the input. Now, we are checking for the negative half cycle. During negative half cycle, at this particular terminal, we are having negative charge, whereas at this particular terminal, we are having positive charge. This makes our diode to be in reverse bias. And as we know that whenever the diode is in reverse bias, it will act as an open switch. So we are replacing the diode as an open switch, and we can see that the circuit is not getting completed. So during positive half cycle, we won't get any output. On combining these two positive and negative half cycles, we can see that we are getting the same type of output, that is in positive half cycle, we are getting the output. In the negative half cycle, that is the duration from pi to 2 pi, we won't get any output, that is 0. Then again during positive half cycle, we are getting the output. So we can say that half-wave rectifiers are the rectifiers in which we are getting the output only during our positive half cycle, and in negative half cycle we are getting 0 as the output.